Hello and welcome back. We now look at a bit more detail into classes. Previously, we've seen classes as a way to define our own objects, and we used some examples to set up classes in a way that we can reuse code, but also compact elements that belong together in this class. Now we extend this to the concept of inheritance. Classes are a powerful way to define objects with certain properties and capabilities, like the properties are the variables of the class and the capabilities the functions. In the previous example, we used a simple class called the dog. Now, if we were to extend this, we could also have now a second class called cats. And of course, the functionality would be not bark, but meow, as simple a way of describing how the animal would communicate. However, that would replicate a lot of code, because apart from this bark or meow function, the classes would be very much identical. So it would be much nicer to have a way of describing cats and dogs in a more general terms, and then have a more concrete implementation that is then specialized for cats and dogs. And here we can make use of a feature called inheritance. This allows us to create relationship between classes. So we can start with a more generic high-level class that describes everything, for example, that is in common between cats and dogs, and then use more defined specialized classes that inherit from this more general class, and take the relation from this parent class and then extend this functionality to be more specific for cats and dogs. Now, the trick is that designing such a relationship is quite a hard thing to do. On one hand, we want to have a generic setup that we can use several times, and that is quite flexible. In our case, for example, cats and dogs. But the danger is that if we make this too flexible, we run the risk of becoming far too generic, and then it becomes very difficult to derive a proper approach for a problem at hand. So we don't want to have like the super general monster class. So quite often we may find ourselves in a situation to define a set of classes and their relationships, and then we need to sort of step back and think about the problem we are trying to solve and choose the right level of complexity. And we should also try to avoid to over-engineer everything. Admittedly, this sounds a bit vague and tricky because the design of these classes typically isn't straightforward and that easy. So let's think about this a bit more in our cats and dogs example to illustrate the point. So in our case, we have cats and dogs, and we want to have a base class that defines what is common between cats and dogs. So we could call them pets, because typically our cats and dogs are pets. But immediately we see an issue. Cats and dogs are pets, but not all pets are cats and dogs. Or not all dogs and cats are pets. So, for example, we could think of wild or feral cats. They would still be cats, but they are not pets. On the other hand, other people would keep birds or rabbits or something as pets. So they're clearly pets, but they're neither cats nor dogs. So we can have several approaches now. We can have pets as our base class and specify it such that it would also work for birds and rabbits, at least in principle. But that would mean that we would have to define our class in a way that it applies to birds, although we really only need cats and dogs. So that might not really work too well. We could limit ourselves to cats and dogs, but not necessarily pets. That also, of course, has its issues, but let's take this approach for now. So how would we define a base class for this? One way is to go up in the taxonomy of animals as a starting point and see where on which level cats and dogs sort of start to differ. So both cats and dogs belong to the level of Carnivora. And then for cats, we go into Felidae, and for dogs, we go into Canidae. And the order of Carnivora includes also a lot of other animals that we do not want to describe in our derived class, cats and dogs, but we could define classes for them based on this base class. Right? But we don't need to, at least we don't get into a conflict. So the base class could look like this. We have the class, the keyword here, carnivora. Then we have an init, and we take a default argument name, and we leave it as an empty string, because if it's like a feral cat, we don't want to give it a name. But at least we have the general principle that we could give it a name. And we have an access function name that returns this one. And notice here the underscore as a convention to indicate that this is an internal variable that we should not access. We can also set a name as an argument, and we could have the speak function, and this we don't implement because for cats and dogs this is different. So this is what the more specialized class will need to do. So this is quite a generic class, and we can use it for our cats and dogs, and we could also, at least in principle, do it for bears, but we don't really need to. Remember here that we've used the bark function for dogs, but now we use the more generic speak function because the cats meow and don't bark. So for now, the function doesn't do anything. It would be better if it would raise a not implemented error, but we come to this when we do exception handling a bit later on. Since we don't want to use this class directly, we start implementing the class dogs. Now we need to inherit from this class carnivora, and this is by extending the class definition. We have class as before, the keyword, then the name of the derived class, and then in brackets the base class we want to inherit from. Python, as opposed to other languages, also supports multiple inheritance, so we can have class, name of the class, and then all the classes we want to inherit from. But beware, this can work very well, but it increases the complexity of the design very quickly. If you find yourself in a position where you need to inherit from more than one class, by all means do so, but think if this is really the best thing you need to do. Now let's implement our derived class. We have the keyword class, call it dog as before, and now we inherit from the class carnivora, which we've defined above. We have the init function again, note the magic init. And now we need to not only initialize this class, but we need to pass this on to the base class, the parent class. Because the name is part of the implementation of the base class. If we scroll up again, we see here the initialization is part of carnivora. So we need to pass this on upstream, so to say. And the only thing that we need to implement is that speak, the function speak, and here we say woof. Everything else we inherit from the carnivora class. So now we create an instance, notice again lowercase versus uppercase, give it the name Rocky, and then we let it bark. As an exercise, do the same thing for a cat.